Good evening, everyone. It's long time we met for the continuation of the syllabus. Right, so let's get started with circular motion. So, in linear motion, in one dimension motion, in rectilinear motion, we had a point moving along a straight line. Its position measured from origin point O called origin, and distance from that point towards right was considered positive, or that positive, like one is towards right is positive, left is negative, or towards left is positive, right is negative. But now, instead of having rectilinear straight line motion, we have motion along a circle. Now, what's a circle? Circle is the locus of all the points, which is at a constant distance from a center, from a point called center. And this distance is called radius. That point is called center of the circle. So we are going to study circular motion where particle moves along this path, which is at a constant distance from a point called center, and this constant distance is called radius of the circle or circular path. Now, to measure angle, in circular motion we measure angles, alright? In rotational motion, circular motion, we measure angles, angular quantities. So angular position is measured. We require two things to measure angular position. One is the point and one is the reference line. If I consider this to be the reference line, this is my angle theta, which is measured from this line in anti-clockwise sense is positive, clockwise sense is negative. Alright, it's again a convention. You can do it every problem in the other way around also. But you should be careful with the convention throughout the problem. Alright. Now, angular displacement is change in angular position. If this is theta 1, this is theta 2, delta theta is theta 2 minus theta 1. As we have three kinematic equations, theta is equal to, x is equal to ut plus half t square. I have got theta is equal to omega t plus half alpha t square. We'll talk about what is omega and alpha are, but you might have at least come across this before in your usual classes because everyone is ahead of what is going on here. In college, everyone is ahead of what is going on here, right? So you might have at least heard of what omega and alpha are. Omega is angular velocity, alpha is angular acceleration. All right, that will come to that. Now, so delta theta by delta t will give me average angular velocity. So displacement, angular displacement in certain time taken to traverse the angular displacement is my average angular velocity of the particle about its center in the time delta t. All right. Now let's say particle has gone from A to B or position 1 to position 2. A to B, theta 1 to theta 2. So my delta theta is theta 2 minus theta 1. So average angular velocity is theta 2 minus theta 1 by delta t. But then if I tend this delta t tends to 0, if I make this delta t tend to 0, I'll have delta theta becomes d theta, delta t becomes dt, I'll have omega is equal to d theta by dt. As you have got instantaneous velocity in linear motion, rectilinear motion, I've got instantaneous angular velocity here, which is the limit of delta average velocity with as delta t tends to 0. there is one point I want to convey here. You have to remember, I'll prove it later, that average angular velocity is not a vector quantity, but instantaneous angular velocity is a vector quantity. When do you say something is a vector quantity? When it satisfies vector laws of addition. When that quantity has got direction and magnitude, not just that, it should also satisfy vector laws of addition. Alright, that's parallelogram law or triangle law of addition. Only then we call it vector. Now, this does not satisfy, we'll prove it later. And this will satisfy, we'll prove it later. This is a little advanced. This is easy to prove, but I will prove it that omega average is a scalar, but omega instantaneous is a vector quantity. Now, when I say vector quantity, it should have some direction. What is the direction? Direction of omega is this sense. I curl my fingers in the direction of the path of the particle. If my particles are moving anti-clockwise sense, my thumb is pointing upwards, so my omega is upwards. Omega bar or omega naught is out of the plane. If my particles are going from B to A, clockwise sense, if my fingers are curled in the sense of motion of the particles are going from B to A. So my fingers are being curled from B to A. My thumb points inwards. So omega is inwards. So omega is either outwards or inwards. Omega is an axial vector. It is not like velocity which can be in any direction, linear velocity. But it's an angular velocity. Angular velocity is only along the axis of the circle, which is either out of the plane or into the plane. It has got no other random direction. So whenever you talk of omega, think of it as an axial vector, which is either out of the plane or into the plane. It is out of the plane when the particles are going in anti-clockwise sense. My fingers curl in anti-clockwise sense. My thumb points outward. It is into the plane when my particles are going in clockwise sense. That is, my fingers curl in a clockwise sense and my thumb points inwards. All right. Now let us see. So all the angular quantities are axial vectors. Omega, alpha are axial vectors. That means they are along the axis of the circle, of the circular path. Now let us say theta is given as Pt plus Ct square. I have to find out omega, instantaneous angular velocity. So how do I do it? Which is nothing but d theta by dt, which is nothing but derivative of Pt is what? What is derivative of Bt?
Sir, it is B, sir.
Good. P. What is derivative of Ct square?
2CT, sir.
2Ct. So that's the angular velocity. Right. Now,
So can you turn off the spotlight?
oh, again, sorry. All right. Now let us understand. As you had constant angular accelerated motion, uniformly accelerated motion, you have uniformly accelerated angular motion, circular motion, where you have got constant angular acceleration. All right. So that's the first basic thing we are going to deal with. So let's say I've got a circle like this. The particle is moving on this circle with some velocity v naught at certain instant. Radius of the circle is r naught. This is the axis of the circle. So what's the omega? Is the omega upward or downward for the particle? I curl my fingers in the direction of the motion of the particle. Upwards. Right?
Yes.
So omega is upwards. So either omega will be upward or downward. It will have no other random directions. But linear velocity will have random directions. As the particle goes over here, it will have velocity this way, velocity this way, velocity this way, velocity this way. But omega is going to be constant upwards. If the particle were to rotate clockwise, then omega would be downward. That's fine. But now, But now let us say alpha is also upwards. What does it mean when I have alpha is, if alpha and omega are same direction, omega is going on increasing. What does omega increasing mean? Omega increasing means the particles is going on speeding up. Because omega is increasing means particle has my curl of fingers, my fingers are curling faster than before. They were speeding up, circulating like this for some omega. When omega increased, they went on speeding up. So this particle's linear speed is increasing. That's what we can observe. If omega is increasing, but particles linear speed, their relation we'll look into it in a while. But if particles linear speed is increasing, my omega is increasing. Or if omega is increasing, I can say linear particles linear speed is increasing. If alpha is in the same direction, my omega goes on increasing. If alpha is in opposite direction, my omega goes on decreasing. So we say it's retarding when alpha and omega are opposite directed. When alpha and omega are in the same direction, we say circularly it's speeding up. When they're in opposite directions, slowing down. Alright. See, I just told you qualitative aspect of this alpha and omega. We'll look into the equations in a while. If we have time, we'll look into the equations in a while. Now, if a particle is randomly going like this at a distance of L naught, going in this direction velocity V naught at an angle of 30 degrees. So I stand on this point O. If I fix this point, now this point is also rotating about this point at this instant. If I have to find out the angular velocity of this point about this point O, about of the point P or the particle P, about this point O, the definition is angular velocity is given by V perpendicular by perpendicular distance. V perpendicular by perpendicular distance omega of the particle about any point O. For this random point O, distance is L and V perpendicular is what? What is V perpendicular here? V is this way, perpendicular of that is this way. So V sine theta is my V perpendicular, which is V by 2. So V by 2 by T L naught. So V naught by 2 L naught. So V perpendicular by distance into the 2 points. And what is V perpendicular? Perpendicular velocity component of the velocity perpendicular to the line joining the 2 points. Line joining center, line joining the reference point and all the particle. You all understand this? This is what I am finding out the angular velocity of the particle at a certain instant about certain point O in space or in this plane. అది సర్క్యులర్ లో మూవ్ అయితే థింగ్స్ ఆర్ డిఫరెంట్ థింగ్స్ ఆర్ సింపుల్ ఒమేగా ఉంటుంది ఆల్ఫా ఉంటుంది థీటా ఉంటుంది అండ్ ఈక్వేషన్స్ విల్ బి యూటీ ప్లస్ హాఫ్ టీ స్క్వేర్ v square minus u square is 2s similar equations వస్తాయి we'll come to that but right now I'm telling you if a particle is going at some random velocity v naught at an angle theta with the line joining O and P, what is the angular velocity of this point about this O at this instant? How do I do it? Angular velocity is always given as v perpendicular by distance between the 2 points joining particle and the center, or about which the particle is circulating, considered to be circulating at that instant. This is instantaneous, all right? This is instantaneous. Okay, now let's look at this one now. I've got
Sir, angular velocity ante
angular velocity అంటే ఏంటంటే rate at which this angle is changing. చూడు linear velocity అంటే ఏంటి? Rate at which position is changing, right?
yes sir.
dx by dt, rate at which position is changing. The rate at which angle is changing is angular velocity.
Okay sir.
All right. And how is angle measured? From a reference point and a reference line. I need two things to measure an angle. Okay, now let us say I've got point here at distance d from this point O, a particle is going in towards right, horizontally towards right, with velocity v naught at distance d from this point. I have to find out the velocity, angular velocity of this particle p about O. What do? I join these 2 points. I find out b perpendicular. What is b perpendicular? If the angle length, how much is this angle, students? 45. Because this is d 45. Isosceles triangle. Isosceles right angle triangle.
Yes, sir.
So ఇది 45 అంటే ఇది కూడా 45. So v sin 45 అంటే ఎంత ఉంటుంది? v naught by root 2. So my v perpendicular is v naught by root 2 by distance between them. Distance is the point and the particle. ఎంత ఉంది distance? What is the distance from here to here? If this is d, this is d. Pythagoras theorem says ఇది ఎంత ఉంటుంది?
2d square.
d root 2, right? So that will be v naught by 2d. Is my angular velocity of this point about this point at this instant. All right. Now, this is when this point is stationary. Let's say this point is also moving. It is stationary ఉన్నప్పుడు v perpendicular by distance is my angular velocity. But what if this point is also moving? Then what do is, instead of having v perpendicular, I'll have v relative perpendicular. Ante, let us say this point is O is going upward with velocity v naught, and is going towards right with velocity v naught. Perpendicular direction లో relative velocity తీసుకుంటాను. What is the perpendicular direction? ఇక్కడ v naught by root 2. ఇది v naught by root 2. So this is going towards right with v naught by root 2. This point is going towards left with v naught by root 2. I'm just considering the perpendicular picture. I'm not bothered about what is happening radially. Perpendicular to the rod, perpendicular to the line joining O and P, ఏమవుతుంది? v naught by root 2 ఇలా ఉంది, v naught by root 2 ఇలా ఉంది. What is the relative velocity between these two? They are going in opposite directions. So I add them.
Yes,
v
sir.
naught by root 2 plus v naught by root 2. 2 v naught by root 2, which is nothing but v naught root 2. Divided by t root 2. T root 2 gets cancelled. V naught by d is my angular velocity when this is also moving. So in general, it is component of relative velocity of A with respect to B perpendicular to the line joining particle in the reference point. I'll first take components. ఇది ఒక velocity ఇలా v naught వెళ్తుంది. ఇది alpha. ఇది v naught prime తో వెళ్తుంది. or v1, v2 with beta. Now, what is the relative velocity perpendicular to the line joining O and P? V sin beta, v1 sin alpha, v2 sin beta. So v1 sin alpha
Sir,
plus v2 sin beta by distance between them. Let's say L. This is my angular velocity of the point P about O.
sir. Sir,
Yeah.
can you write more darker?
Oh, yeah. Sorry. I'll change the pen. Sorry. Okay. All right. So I'll just write it again because it's very light. V1 alpha, V2 beta, point O, point P. So angular velocity of this point with respect to this point is V relative perpendicular, that is V2 sine beta plus V1 sine alpha by distance between them, L, is my omega of P with respect to point O. Alright. Okay, now let us say there's a particle moving in a circle. Particle is moving in a circle like this with velocity V naught. The radius of the circle is R naught. About this point, I have to find out the angular velocity of this particle about this point O. So what is it? V is perpendicular to R already because it's going tangentially. V is already perpendicular to R. So what is V perpendicular? V naught by distance between them, R naught, is my omega. But if I have another point over here, O prime, I have to find out the angular velocity of this point P or the particle P about this point O prime at this instant. So what do? V perpendicular is V naught by distance between them is 2R. So omega prime is V naught by 2R naught. Now because Bhavna asked, here is a case where you can explain what is Bhavna asked, what is angular velocity. Let us say particle has moved till here. ఇది theta ఉంటుంది. By properties of circles, this is theta by 2. Alright, we can prove that. That's not a big deal, na? This is theta by 2, right?
Yes, sir.
Yes, sir.
Look at this. ఇది చూస్తే ఏముంది? This is half of this one. Angular velocity of this omega prime, about O prime is half the angular velocity about O. In a certain time, if it is moving angle of 60 degrees ikkada, it is moving only traveling an angle of only 30 degrees ikkada
30
about this
degrees.
point O prime. So it's half the angular velocity. So angular velocity is what? Rate of change of angular displacement or angular displacement traversed in unit time taken if it's uniform. Alright. Okay, when it is this point, we'll find out what happens at this point. V naught ఇలా move అవుతుంది. This is R naught. This is O. Let's say this is 60 degrees. This is 30 degrees. I have to find out V omega P about O prime, omega P about O. About O it is same because of V naught by R itself, because V perpendicular is V naught, distance is R. About in a circle, omega is constant. If it is going with constant speed, omega is constant. That's what it's turning out to be, right? What is omega definition? V perpendicular by distance. What is V perpendicular? V perpendicular is V naught, but distance is R naught. And R naught is remaining constant, V naught is remaining constant, so omega remains constant. But about O prime, V perpendicular ఏముంటుంది ఇప్పుడు? If this is 30, this is 60, this is 30. So V
30.
naught sine 60. So V naught root 3 by 2 is my V perpendicular by distance. What is the distance now? E distance. E distance ఎంత ఉంటుంది? If this is R naught cos 30, R naught cos 30. 2 R naught cos 30. 2 R naught cos 30 ఎంత? Root 3 by 2. Root 3 by 2 gets cancelled out. I'll get V naught by 2R. So do you understand how to calculate angular velocity of a point about some other random point, whether the point is moving or not?
సో అర్థమైంది కానీ మరి ఈ సైన్ అండ్ కాస్ట్ లో కన్ఫ్యూజ్ అవుతున్నాం సార్.
Okay, the
Yes.
angle
My
shown, huh?
part. Yeah, sir.
Okay. Angles
Okay.
are angles is
Yes.
okay. I'll just show you the angles. I'll magnify this and show you the angles. Angles are very simple, not a problem. Omega అర్థమైతే చాలు, angles మళ్ళీ చెప్తాను, not a problem. ఇది 60 degrees, ఇది perpendicular, alright? ఇది 30, ఇది కూడా 30 ఉంటుంది. ఇది పర్పెండిక్యులర్ కాబట్టి ఇది 60 ఉంటుంది.
Yes,
Now
sir.
because this is this way, perpendicular to this will be like this. ఇలా ఉంటుంది perpendicular. Now this is this perpendicular. This is perpendicular to this one, tangent. But this is not tangent. This is perpendicular to this vector, O prime P. ఇది O prime P కి perpendicular. If this is 30, this is 60. If this is 60, this is 30
Yes,
because it's
sir.
90 degrees. ఇది V0. Now I want component of V0 along this perpendicular. అదే కదా relative velocity definition. Angular velocity definition is V perpendicular by distance. What is V perpendicular? Component of V0 along the perpendicular to the radius
Not
vector.
30, no, sir.
V0 cos 30.
Yes, sir. V0 by
V0 root 3 by 2.
3 by 2.
Yeah, that's it. Okay. So అది 30, V0 cos 30, I'll have V0 cos 30 is nothing but V0 root 3 by 2 by R0. This is a perpendicular right angle triangle. R0 cos 30, R0 cos 30. 2 R0 root 3 by 2. Root 3 by 2, root 3 by 2 gets cancelled out. I'll have V0 by 2 R0. Okay. Is it okay, students? ఇప్పుడు అర్థమైంది కదా, angles are not a problem. I had 60, 30, 60, 30 అలా వేసుకుంటే వెళ్ళిపోతే వచ్చేసింది అంతే. All right. Now let's go further.
Step. Answer.
Sorry?
Answer.
Answer is V0 by 2, V0 by 2 R0.
Sir, ఎట్లా వచ్చింది సార్?
Velocity perpendicular component ఏంటి? V0 root 3 by 2. By distance between the 2 points ఏంటి? Radial distance 2r cos theta. R cos theta, R cos theta. R cos 30, R cos 30. 2r cos 30. 2r into
Yes.
cos 30. Cos 30 root 3 by 2, root 3 by 2 cancel అయిపోయింది. ఏం మిగిలింది? V0 by 2 R0 మిగిలింది.
Yes, sir.
Okay. Now let's understand one thing. ఇప్పుడు చూడండి, I told you omega is the axial vector, right? And I got V is equal to V by R. V by R is equal to omega వచ్చింది నాకు. Right? So V is equal to R omega or omega times R. కానీ ఇప్పుడు omega is a vector, R is a vector, V is a vector. I cannot multiply two vectors like this, I can multiply either using a dot product or a cross product. If at all I have to multiply two vectors, I cannot just simply write two vectors like this, omega into R. Either there should be omega dot R or omega cross R. ఇది V0 కూడా వెక్టరే కాబట్టి this should be a cross product. ఇప్పుడు cross product ఎలా వస్తుందని చూద్దాం. I've got omega, let's say particle is going in this direction. V0 anti-clockwise sense. If this anti-clockwise sense, my thumb direction is outward, so my omega is outward. And radius is R0. Now, look at this. Omega cross R is my V bar. So it's a cross product of omega and R, not R cross omega, it's omega cross R. They are not commutative. You remember, A cross B is not equal to B cross A. It's actually minus of B cross A. So omega is outward, cross R. R bar is the origin కాబట్టి R bar ఇలా ఉంటుంది, V bar ఇలా ఉంది, omega outward ఉంది. So omega cross r is v bar. So v is equal to omega cross r. This is what you have to remember. Now, if omega is, let's say, inside into the plane, so omega cross r, v will be in this direction. Appudu clockwise sense vastundi. So this vector equation, vector definition is perfect now. It's matching. Everything is being perfect. ఇది యాంటీ క్లాక్ వైజ్ వెళ్తే బయటకు వస్తుంది, ఇది క్లాక్ వైజ్ వెళ్తే ఇది లోపలికి వస్తుంది. రైట్ హ్యాండ్ థంబ్ రూల్ లో ఏమొస్తుంది సేమ్ థింగ్ ఐఎమ్ గెటింగ్ విత్ వెక్టర్ ఈక్వేషన్ ఆల్సో. సో v is equal to omega cross r is a vector equation for relation between linear velocity v, angular velocity omega, and radius vector r naught. All right. Now let's do one thing. Let us differentiate on both the sides. I'll differentiate this dv by dt. And how do I differentiate product of two functions? Differentiate ఎలా చేస్తారు product of two functions? అయిపోయింది అది. Like you know how to do it? f into g, derivative of f into g. fg dash plus gf dash.
No, sir.
No? Okay, I'll tell you. If I've got two functions f of x and g of x, if I have to differentiate this with respect to x, this will be equal to f of x into d by dx of g of x plus g of x into or d by dx of f of x into g of x. So fg dash plus f dash g is my derivative of product of two functions. fg dash plus f dash g. Turn by turn I'll differentiate and multiply that with the other function. f of x into multiplication of f of x with g dash x plus f dash x multiplied with g of x. So fg dash plus f dash g is a derivative of product of two functions. So same thing what I'll do now, v is equal to omega cross r dv by dt is equal to, I'll write omega times omega cross dr by dt
Kevin, sir.
plus d omega by dt times cross r.
Arun, sir.
Yes,
అక్కడ v అనేది వెలాసిటీయా?
yes, linear velocity of the particle. ఇప్పుడు సర్క్యులర్ డ్రా చేశాం కదా, టాంజెన్షియల్ velocity of the particle is v.
సో మనం వెలాసిటీని dx by dt రాసుకుంటాం కదా సార్.
Linear velocity, అది rectilinear motion. Otherwise it is dr by dt. See, rate of change of position is velocity kada.
Yes, sir.
So what is position here? R bar is position here. Position vector is r bar. So rate of change of this position vector is v bar. అది rectilinear motion లో వన్ డైమెన్షన్ x ఉంటుంది కాబట్టి x రాస్తాము, dx by dt రాస్తాము. Otherwise it is actually dr by dt.
Yes, sir. అర్థమైంది.
Right. Now dr by dt I can write it as v. So omega times omega cross v bar plus alpha cross r bar. Now I've got two common. Now what is this a bar? dv by dt is nothing but a bar. Sorry?
సార్ ఆల్ఫా ఎందుకు వచ్చింది సార్?
Alpha ఎందుకు వచ్చిందంటే see, rate of change of position is velocity, rate of change of velocity is acceleration. అలానే rate of change of angular position is angular velocity, rate of change of angular velocity is angular acceleration.
ఓకే సార్.
సో ఇక్కడ ఇంట్రడ్యూస్ చేశాను, ఆల్ఫా ఇంట్రడ్యూస్ చేశాను నేను. సో రేట్ ఆఫ్ చేంజ్ ఆఫ్ యాంగులర్ వెలాసిటీ ఇస్ ఆల్ఫా. ఇప్పుడు ఇది చూస్తే నా టోటల్ యాక్సలరేషన్ ఇస్ సమ్ ఆఫ్ టూ టర్మ్స్ నౌ, వెక్టర్ సమ్ ఆఫ్ టూ టర్మ్స్. దిస్ ఇస్ కాల్డ్ centripetal acceleration AC and this is called tangential acceleration AT. సెంట్రిపిటల్ అంటే ఏంటి చూద్దాం. ఇప్పుడు ఒమేగా క్రాస్ వి చూద్దాం ఎలా ఉంటుంది. ఒమేగా పైకి ఉంది, క్రాస్ వి. ఓకే, I'll erase this and draw it properly. So A bar omega cross B bar plus alpha cross R bar. If B bar is this way, omega is out of the plane. So omega cross B, choose the amount of the omega cross B towards center ఉంటుంది. That is AC bar. Centripetal acceleration. It's called centripetal because it's towards the center always. Towards the center, about which the particle is rotating at that instant. Alpha cross R చూద్దాం ఎలా ఉంది. I said it's tangential acceleration. So it should be tangent along the tangent, right? అందుకే tangential పిలిచారు. Alpha is, let's say, upward. Alpha cross R. Alpha can be upward or downward. Depends on omega is increasing or decreasing. Omega increase అవుతుంది అనుకుందాము. There are only two possible directions of alpha. Upward, outward or inward. Omega, alpha are axial vectors. They are along the axis of the circle. ఎప్పుడైనా గుర్తుపెట్టుకోవాలి. The moment you think of omega and alpha, మీకు two vectors ఇక్కడ కనపడాలి. Along the axis కనపడాలి. మీకు tangential velocity of the particle be tangent to the trajectory ఎలా కనపడుతుంది? అలా velocity of the particle, angular velocity of the particle and angular acceleration of the particle should be seen along the axis of the circle. All right. So alpha, let us say, is outward. So alpha cross R. R ఎక్కడ నుంచి ఉంది? This is my origin. This is my R bar. Alpha cross R is tangent to this. That's why it's called tangential acceleration. Now look at the students. I told you if omega is increasing, alpha is out of the plane. Omega increase అవుతుందంటే V ఏమవుతుంది? Increase అవుతుంది. That means AT should be parallel to V. I repeat. AT, okay, let's say alpha is into the plane అనుకోండి. If alpha is into the plane, so omega is decreasing. Alpha cross R. AT is out downward now. That means what will happen to V eventually? We will reduce. Speed of the particle reduce. ఇలా తగ్గుతూ ఆగిపోతుంది. ఆగి మళ్ళీ వెనక్కి వస్తుంది. సో ఒమేగా అండ్ ఆల్ఫా విజువలైజ్ చేయడానికి యూ కెన్ విజువలైజ్ V and AT. V and AT ని విజువలైజ్ చేయడానికి you can take the help from omega and alpha. Omega and alpha are opposite in direction. That means omega is going on decreasing and then flip. Omega decreases అవుతుందంటే ఏంటి? What's the meaning? This particle is slowing down on the periphery, stopping and then reversing in direction. It's sensor reverse అయిపోతుంది. That's what omega is flipping. Omega flip అవుతుందంటే it's anti clockwise నుంచి clockwise అవుతుంది or clockwise నుంచి anti clockwise అవుతుంది. But here it is, let's say, flipping from outward to inward. Omega is flipping from outward to inward. అప్పుడు ఏమైంది? Particle is going like this, stopping and then becoming clockwise. Now let us say I've got a particle. ఇక్కడ ఒక వాల్ ఉంది, some obstruction ఉంది. ఇక్కడ నుంచి ఒక పార్టికల్ ని ప్రొజెక్ట్ చేస్తాను V0 తో. రేడియస్ ఇస్ R0. ఇలా వెళ్ళి ఇలా హిట్ అవుతుంది. హిట్ అయ్యి మళ్ళీ రిటర్న్ వస్తుంది. When it hits here, it goes on oscillating like this forever. Let's say there's no friction, there's no loss of energy, there's no coefficient of restitution is 1, there's no loss of energy at all. It goes on forever, continues forever. అయితే ఏమవుతుంది omega? When it goes from here to here, omega is outward. The moment it hits, my omega flips. Omega becomes inward. It becomes clockwise. So omega goes on flipping.
Up and down అవుతుంది సార్.
Sorry?
అప్ అండ్ డౌన్ అవుతుంది సార్.
Sorry?
కిందికి పైకి అవుతుంది సార్ ఒమేగా.
ఎలా అవుతుంది అంటున్నావా?
నో సార్, మీరు అన్నారు కదా ఒమేగా ఎక్కడ అవుతుంది అంటే ఐ మీన్ ఇంటూ ద ప్లేన్ అవుట్ ద ప్లేన్ అని అన్నారు.
Yeah, out of the plane, into the plane అవుతుంది. That's what you're saying?
Yeah sir.
Oh, you're asking or telling?
I'm telling sir.
All right, good. All right, I got it. Yeah, I thought you were asking something. All right, good. So omega is going on flipping. కిందికి పైకి అవుతుంది. It will become outward, inward, flipping. That too abruptly. The moment it collides, omega flips. It becomes clockwise. The moment it collides again on the left side, it again flips. Omega becomes anti-clockwise. Omega becomes outward. So motion is anti-clockwise. So that goes on happening. All right. Okay, now this is AT and AC. Now let us say, now we have seen angle between vectors is 90 degrees. In this case, angle between vectors is 90 degrees. Omega, alpha, R bar are all 90 degrees. Omega and R bar is 90 degrees. Omega and B bar is 90 degrees. Alpha and R bar is 90 degrees. So I can write this as omega is equal to B is equal to R omega. I can write, right? I know that B is equal to R omega, right? Or omega into R. So I can write omega square R plus R alpha. Or I can also write it as V square by R plus R alpha. This is along the radius. This is along the tangent. This is along the radius towards the center. That's why I kept minus R cap. All right, look at this. Minus R cap, minus R cap. And this is along theta cap, along the tangent. So my radial centripetal acceleration is omega square R or V square by R. My radial tangential acceleration is R alpha or alpha R. So if I ask you what is my total acceleration, this is a vector form. What is the magnitude of the total acceleration? This square plus this square under root. Because they are perpendicular in direction. See, AC ఇలా ఉంది, AT ఇలా ఉంది. So resultant will be somewhere here. This square plus this square under root is my resultant acceleration. And that angle will be tan inverse of AC by AT. ఇది theta అనుకుంటే tan inverse of AC by AT with tangent. ఇది or with radius అనుకుంటే AT by AC. Alright, these are all things we have done it vectors, right? So that's not that big a deal. All right. So any doubts so far, students?
No, sir.
If you have no doubts, we'll stop here. If you have doubts, I'll discuss those doubts and close session, end the session. Anyone has got any doubts? There's a message. Let me check the message.
సార్ ఒకసారి మళ్ళీ చెప్పరా సార్ ఇది?
ఏది ఇదా ఈ క్వశ్చన్స్?
yes sir.
Okay. A bar is equal to omega cross V bar plus alpha cross R bar. This is called centripetal. This is called tangential. This is called centripetal because it is towards the center. It is called tangential because it is along the tangent to the path. ఇది చూద్దాం centripetal ఎలా వస్తుంది చూద్దాం. This is V bar. This is R bar. Omega is out of the plane. If omega is out of the plane, I place it here. Omega cross V is towards the center. Look at this. Omega cross V, thumb direction is my direction of the cross product. Omega బయటకు ఉంది. Why is omega బయట?
Sir.
Omega బయట ఎందుకు ఉంది? Outer ఎందుకు ఉంది? Because it's an anti-clockwise sense. My fingers are curling in the direction of motion of the particle. My thumb is pointing outward.
Yes.
Omega is outward.
Yes sir.
Omega outward అంటే ఇక్కడ omega డ్రా చేసుకొని or V ని ఇక్కడ డ్రా చేసుకొని omega cross V చేస్తాను. Cross product తీసుకుంటా 2 vectors ది. I'll get cross product direction ఏమొస్తుంది? Thumb direction, cross product direction వస్తుంది. Which is towards the center.
Sir. Sir.
Yeah.
మనం thumb rule ఎందుకు వాడుతున్నాం సార్ ఇక్కడ?
See, cross product is a mnemonic. Cross product కోసం మనం ఏం చేస్తాము? When I have two vectors, let's say A and B, B 2 vectors ఉన్నాయి. How will I get the direction of cross product ఎలా తెచ్చుకుంటాము? A cross B ఎలా
crossword.
తెచ్చుకుంటాను? I'll rotate my palm from A to B, from A to B around about lesser angle, not this angle but this angle. Thumb direction is my cross product. Magnitude ఎంత ఉంటుంది? ఇది theta అంటే AB sin theta ఉంటుంది magnitude, and direction is out of the ఇప్పుడు కూడా క్రాస్ ప్రోడక్ట్ కావాలి కదా, నాకు డైరెక్షన్ క్రాస్ ప్రోడక్ట్ కావాలి. ఇఫ్ యూ కెన్ క్విక్లీ టెల్ ఇట్, డూ ఇట్ ఇన్ యువర్ మైండ్ సైజ్ ఇస్ ఫైన్, అదర్వైజ్ యూ కెన్ యూజ్ యువర్ హ్యాండ్ పామ్. ఒమేగా క్రాస్ బి చేస్తాను. థంబ్ డైరెక్షన్ ఇస్ మై డైరెక్షన్ ఆఫ్ ద క్రాస్ ప్రోడక్ట్, which is direction towards the center. AC ఉంటుంది. Because it's towards the center, it's called centripetal acceleration. Omega into V ఎంత? Omega V sin 90 degrees కాబట్టి angle between them is 90 degrees. So omega V sin 90 అంటే omega into V. Omega into V. What is V? Omega into R. So that becomes omega square R. So omega square R is my centripetal acceleration. Now let's see radial acceleration. Alpha cross R, tangent to it. So ఇది tangential acceleration. And angle between them is 90, so it becomes alpha R alpha or alpha R. Resultant acceleration is somewhere here, which makes an angle with a tangent. How will I get the resultant acceleration? Pythagoras theorem. This square plus this square under root. ఒకవేళ ఆల్ఫా లోపల ఉంది అనుకుందాము, ఆల్ఫా is into the plane, then alpha times R is downward, which means this particle is retarding. If this particle is retarding, this is going on slowing down. If this is going on slowing down, if this is going on, slowing down, then omega is going on decreasing. That I can also conclude from alpha and omega, which are in opposite directions. Omega బయటకు ఉంది, alpha లోపల ఉంది. So omega will decrease. I can do that from tangential picture also. What is happening to tangential velocity or linear velocity of the particle? Tangential speed ఏమవుతుంది? డిక్రీజ్ అవుతుంది. అలానే నేను ఒమేగా ఆల్ఫా చూసి కూడా చెప్పొచ్చు. వాట్ ఈస్ హ్యాపెనింగ్ టు, ఇక్కడ ఎలా డిక్రీజ్ అవుతుంది చెప్తున్నాను. AD is opposite to V. That's why V is going on decreasing. ఇక్కడ ఎలా డిక్రీజ్ అవుతుంది చెప్తున్నాను. ఒమేగా అండ్ ఆల్ఫా in opposite direction. So omega decreases. అదే ఒమేగా ఆల్ఫా both are same direction అనుకోండి. So AD is in this direction, which is speeding up. The particle is speeding up. That means my omega is increasing. అది నేను ఇక్కడ నుంచి కూడా చెప్పగలుగుతాను. Omega and alpha are in the same direction, so the omega goes on increasing. Now if I consider a case, simplest case, a collision. ఇక్కడ ఒక వాల్, ఇక్కడ అబ్స్ట్రక్షన్ పెట్టుకొని ఇక్కడ నుంచి ఒక పార్టికల్ ప్రొజెక్ట్ చేస్తే, ఆర్ ఇక్కడ నుంచి ప్రొజెక్ట్ చేస్తే, పార్టికల్ గోస్ టువర్డ్స్ దిస్, హిట్స్ ఇట్, comes back, hits it, comes back, hits it, goes on. So for every periodic interval of time, it's going on flipping. What is flipping? Its angular velocity is flipping. Anti-clockwise sense వెళ్తున్నప్పుడు angular velocity is outward. The moment it hits, angular velocity suddenly flips. Suddenly లోపల వెళ్ళిపోతుంది. Into the plane, it clockwise అవుతుంది, మళ్ళీ హిట్ అవుతుంది, మళ్ళీ ఫ్లిప్ అవుతుంది. So it goes on flipping. Bhavna, is it okay?
Yes, sir.
All right. Anyone else has got any other doubt? If you have got no doubt, we'll end the session here. See you tomorrow again. Tomorrow we'll do dynamics of circular motion. We were doing kinematics of circular motion. We talked about centripetal and tangential acceleration. We'll do dynamics of circular motion tomorrow, and we'll do some problems. And we'll go ahead with dynamics close to we'll start with work per energy. All right, dynamics lo koncham undi. All right, there is some part to be dealt with. That's a little tricky. Pseudo force మంచిగా అర్థమైతే dynamics easy అయిపోతుంది. All right, that's all for today, students. Bye everyone.